Recording. Okay, we begin with our discussion on time series analysis. This is a very important topic, especially in finance, because many of the data that we work on and analyze are time series. No? So later on, we'll describe what is a time series. So I have included here some references. Okay. Some references. Please go over this. Okay, so hindi na muna natin titingnan to, but for example, later on we're going to study what AR and MA is. So these are models for time series. Yung auto-regressive, sulat ko lang dito, auto-regressive and moving average. These are models used for time series. So kapag pinag-uusapan natin ng time series, either AR model yan or MA model or ARMA model, combination ng dalawa, ARMA. No? So here you have some guides, online stat lesson. So you can refer to this later on or when you review this lesson. Tapos meron pa ditong how to write AR equation with seasonality differencing. So medyo advanced topic na to yung number 2. Okay, and then these are excellent resources. Okay, kasi hindi sufficient guys yung discussion lang natin dito. Napaka-ikli ng time natin. So I would that you also read on your own outside this class. Okay, so there are certain time series that we're going to use. Forecast, FPP3, quant mode, etc. So some of this we're going to really use ggplot. Sa plotting to hindi masyado. No? Urca sa paggamit natin later on sa pagmodel ng volatility. No? Pag nag-arch modeling na tayo. Okay, so let's just run this. Na lang guys. You know what to do guys kung walang kung wala pa kayong hindi pa hindi pa naka-install sa inyo. You can, of course, okay, saan ba to? You can either install or pwede nang dito na lang kayo sa packages, no? So for example, pwede nyo, kung wala pa kayong forecast na package, you can install it here, di ba? Pwede kayong mag-install dito. Dito, install, for example, under packages. And then ilagay nyo kung ano yung pwedeng multiple yan guys, no? May comma. On our forecast, comma, FPP3, etc. Okay, so I'll just give you a few minutes guys. And once you're done, once you have installed this and required it, paki-chat ng yes, no? So ito yung mga packages na gagamitin natin ngayon. Let me first pause our recording. Okay, what's time series analysis? Okay, it's both a science, no? It's both a science and an art. It's just like finance, no? Ito na consider siya as science and also an art. So in time series analysis, we try to extract meaningful insights. Okay, we try to make sense of the data, of the time series data. So we look at the structure, the characteristics, and we look at the patterns of the time series data. And goal natin dyan, of course, not only understanding the data, but also forecasting the data so for future use of the data. So kunyari, sales, no? A company would like to forecast sales for the next, let's say for the next 1 year, monthly data kunyari for the next 1 year, so that it can prepare accordingly. Especially sa production, kunyari yung mga materials sila nanggagaling pa sa abroad, so may travel, may may logistics considerations pa yon. So maraming practical na application ang time series analysis. Okay, now how do we model time series? There are different approaches to modeling time series, but what we're going to make use is the one of the most popular one, the Box-Jenkins approach. Okay? So hanapin nyo lang guys kung sino yung Box-Jenkins na to. Okay, they're responsible for modeling, no, time series using this approach. Marami pang ibang guys, no? Marami pang ibang methodology. Okay, we have exponential smoothing, we have mga Holtz-Winters method, marami yan. So many, but for us, ang usually ginagamit sa financial data is the Box-Jenkins approach. Okay? So yung Box-Jenkins approach, as I mentioned a while ago, sila yung nag-formulate ng ARIMA model. Yung ARIMA model, ang composition niyan, AR, MA, at saka yung I. No? AR stands for autoregressive. Pag sinabi natin na we're using an autoregressive model, we are modeling the time series based on past values of itself. Okay, so kunyari meron tayong let's say GNP na data. Okay, so we try to model the GNP data by using the past values, no? Okay, so yun in a nutshell ganun yun, no? Yung MA naman ang ginagamit natin yung error terms niya. Yung error terms ng model. So that's a moving average model. Yung isa naman, autoregressive. Di ba ang ibig sabihin ng autoregressive? Auto, self. You are regressing the time series on itself, autoregressive. Now, naglalagay tayo ng I, integrated. If we have to difference the data, ibig sabihin ng difference, isa-subtract mo yung time t, yung time t sa time t minus 1 or vice versa to generate a new series, no? Okay, medyo hazy yung pag-explain ko, but we will have an example of that later on. Just be aware that ang gagamitin natin na model, na method is the Box-Jenkins approach. Sila yung nag-formulate ng ARIMA model. Okay, for example, look at this one, guys. AR model. Ano yung AR model? So y sub t is equal to a sub o plus a sub 1, okay, times y sub t minus 1 plus an error term. Okay, so this is an example of an AR1 process. Bakit AR1 process? You notice, guys, si y sub t, ito yung model natin. Ano yung ginamit natin na parameters para i-model si y sub t? Y sub t minus 1. Ito. Take a look at this. Diba? Rine-regress natin yung y sub t data natin on the previous value of itself, y sub t minus 1. That's why it's called an AR1 model, an autoregressive model of order 1. Bakit order 1? Kasi ginagamit natin yung one past value ng series para i-model yung series. So kapag AR2 na yan, guys, ano nangyayari? 2 past values na. Yan, y sub t minus 1, y sub t minus 2. No? Okay, so ganun lang, guys, yung AR. No? Hindi siya ganun talaga kahirap naman intindihin. No? Basta pag sinabing AR2, ginagamit natin yung 2 past values para isama dun sa pagmamodel ng series natin. Okay, take note, our model is, hold on. Okay, so AR2 and AR order P. Pag order P naman, okay, that's that is P. Sorry, medyo ninagkasya dito. A sub P, dapat may times to, no? Para hindi nakakalito. So, lagyan na natin times para hindi kayo malito. Kaso, pag linalagyan kasi ng times, may special na ibig sabihin kasi yung asterisk sa Kaya hindi ko nalinagay, no? Okay, so malilito lang tayo kasi pag may asterisk at saka may asterisk, may meaning yan sa R. So anyway, guys, ang ARP model means that you're using the past P values. No? Kunyari, AR10 yan, so magiging A1, y sub t minus 1, A2, y sub t minus 2, plus A10, y sub t minus 10. So the past 10 values plus an error term. Okay? Clear ba yung guys?
Yes, sir.
Okay. Alright, now I leave you guys to look at what an MA model is. No? Ano ba yung MA model? Moving average. Pag moving average model, hindi yung past values ang ginagamit natin. Ang ginagamit natin yung past error terms. So medyo mapapalitan tong y sub t minus 1 ng epsilon sub t minus 1. Okay? Mapapalitan siya ng not the past values of itself, but the past error terms. So sa MA, guys, ang bida dyan, yung error terms. Okay? So pag kinumbine na natin si AR at saka si MA, ang tawag na dyan ARMA. Kunyari ARMA 1-1. So it's just a combination of AR1 process and MA1 process. Okay? Alright. So generally, pag sinabing MAQ, gamit natin dyan MAQ. Yan. Yung isa ARP process, yung isa MAQ. So it means that Q, order Q, which means Q past error terms. Okay, kunyari MAQ. So that will have an epsilon t minus 1 plus epsilon t minus 2. Okay, ibig sabihin dalawang error terms. Okay, so I left this as is, guys, para i-research nyo kung ano ba yung standard model ng MA1 at saka MAQ. Tapos yung ARMA 1-1, combination lang. Kukombine lang natin si AR1 at saka si MA1. Okay? So ang principle, guys, pag AR process, ginagamit natin yung past values of itself. Okay? Katulad nitong AR1, sabi ko nga, ginagamit natin si times y sub t minus 1. Pag AR2 process, y sub t minus 1 at saka y sub t minus 2, yung nagiging predictors natin. Alright. So, ARMA combination, ARMA PQ is the general term. Ibig sabihin, order equal to P for the AR process and order equal to Q for the MA process. So, kunyari, ARMA 2-1, ibig sabihin yun, 2 past values of itself plus 1 past error term. Okay? Alright, pause muna ako. Clear ba yun so far, guys? Clear ba yung explanation natin? Okay, I hope guys clear yung So, pag sinabing time series, guys, you cannot avoid talking about ARIMA. No? ARIMA. Okay, so by the way, guys, pag sinabing ARIMA, okay, yung I doon, kasi AR, MA, tapos nasa gitna yung I. Ibig sabihin nun, dinifference yung data, okay, to convert it to time series. Mamaya makikita pa natin lalo yan. Okay, so let's move on. So generally, guys, ito yung mga steps ng ito yung steps para to do time series. Number 1, of course, plot natin yung data. We have to look at the data. Okay, plot the data and check the stationarity of the data. Check if the data is stationary. I'll explain in a while ano ibig sabihin ng stationary. Kailangan, guys, yung data natin stationary. Kasi hindi natin pwede magamit yung Box-Jenkins model, yung ARIMA process, kung hindi stationary yung data. Okay, if the data is not stationary, then kailangan maggagawa tayo ng transformation. No? Ano yung mga pwedeng transformation ng data, ng time series data natin para maging stationary siya? Okay, number 1, pwede natin i-difference. Okay, ano ibig sabihin ng difference? Sabi ko nga, may series tayo, no? Y sub t, let me use, okay. Ano lang sa Excel para clear lang, no? Kunyari may tayo, kunyari 1, 1, okay. So may series tayo, no? Kunyari 45, 48, 52, 54. Okay? So this is your time series. Time series yan kasi it's based on time, no? Okay, ang difference time series, what you do is get the difference. This minus this. Yan. Okay? So you now have a series that's different from the original. Ang tawag dito, difference series. Difference. Nag-differencing tayo, no? Okay? Nag-differencing tayo. Bakit natin ginagawa yan? Ginagawa natin differencing, guys, kung yung data natin hindi stationary. Okay? So bakit natin kailangan difference kung yung data hindi stationary? Kasi hindi natin pwede ma-model yung data natin, yung time series natin, kung hindi siya stationary. Kailangan yung data natin stationary, no? Okay, as I said, I'll explain in a while ano yung stationary data. Okay? Kung hindi stationary yung data, hindi tayo pwede makapag-box Jenkins. Hindi tayo pwede makapag-ARIMA. Okay? So, in short, guys, you need to have a stationary data in order for us to model the time series. Okay, pwede naman gumamit ng ibang method, pero sabi nga natin, ang focus natin yung box Jenkins approach. And for a box Jenkins approach, kailangan stationary yung data natin. Okay, guys, is that clear?
Yes.
Okay? Sige, fourth lang ba? Yung iba, guys, paki-chat naman, guys, kung ano, chat or unmute na lang, guys, kung clear so far. Okay. Thank you, thank you. Okay, good, good. All right. So, as I said, guys, kung hindi stationary yung data, may mga transformation tayong ginagawa. No? Number one, pwede natin i-difference yung data. Ano ba ginagawa ng differencing? Pag dinidifference natin yung data, it can make the data stationary. No? Pero nagiging stationary lang siya sa mean. Okay, ibig sabihin, yung average natin, it becomes constant now. Kasi, guys, tingnan nyo ha, okay, balik ako dito. Hindi ko pala na ano yung, hindi ko na ano yung, ano ko, yung digital pen. Okay, let me just insert. Ganito na lang. No? Itinan ko kung may pattern to. Okay yan. Okay. I-plot ko to, guys, ha. Insert. Insert. And then, sorry for this very crude example. Okay. Ano siya? Ganito na lang. Random na lang. Sorry, ha. Run between 50 and 80. Ganito lang. Kaya, eto guys, tingnan nyo ha. Hindi maganda yung example natin kasi okay. Tingnan nyo to guys. Yung average ba nito, yung mean ba nito nagbabago over time? Or constant ba yung mean niya? Constant ba yung average niya, yung mean? Okay, this is an example guys of a data that's constant over time. Ano ba yung ibig sabihin ko kung hindi constant over time? Insert nga ako dito lang. Mamaya na lang guys, no? Hindi maganda Excel na gamitin para sa ano? Sa hindi constant over time. Okay. Balik na tayo dito, no? Okay, so this will become clear later on guys when we have an example. So, ang pinaka-importanting isipin natin dito guys, look at the data, plot it. Ang question, stationary ba siya? Okay, kung hindi siya stationary, we have to transform the data. Yung unang pwede natin gawin na transformation, generate a difference data. Okay, ibig sabihin, mina-minus natin. Yung difference data na yan guys, yun yung sa ARIMA, yung I. Okay? Remember, sabi dito, yung ARIMA natin, saan yan? Yung I dito, yan. Integrated ang tawag doon kasi ang ginawa natin, dinifference natin yung data. Yan. So pag dinifference natin yung data, we're actually using an ARIMA model. Okay? So secondly, pag hindi pa rin guys, hindi pa rin stationary, what you can do is to do log transformation. Ito na yung second, no? Second transformation. Kunin natin yung log ng data. So we can get the log of the difference data. Take note, nag-differencing na tayo, di ba? Okay, so kinuha pa natin yung log. ano naman ginagawa kapag kinuha natin yung log? Nagiging stationary siya sa variance. Okay? Kasi dalawang klaseng stationarity, no? Stationary siya sa mean and stationary siya sa variance. Kailangan pareho siyang stationary sa mean, ibig sabihin wala dapat trend, at saka sa variance, ibig sabihin wala dapat yung very apparent na volatility, no? Okay? So ibig sabihin kapag stationary yung data, wala siyang trend. Okay? And then constant yung mean niya and constant yung variance niya. Okay? Okay, so sometimes pag nag-difference lang tayo, okay na. Sometimes pag nag-log lang tayo, log transformation, okay na. Pero sometimes kailangan pareho, no? Kailangan pareho natin i-difference tapos ilolog pa. Okay, tapos minsan kailangan pa natin i-difference yung log transformation. Nag-log transformation na nga tayo, tapos i-difference pa natin. So depende sa data natin yan. Usually differencing lang okay na eh. Usually log transformation lang okay na. So minsan kailangan pareho, no? Okay, once we have done the transformation, kung naging stationary na siya in mean and in variance, pwede na tayong mag-check, no? We have to statistically check kung stationarity nga yung data. Kasi hindi pa pwedeng visual lang, no? Hindi pwedeng visual lang. Kailangan mag-statistical test tayo kung stationary na yung data. Okay? All right. Then step 6. Okay, once na confirm na natin stationary na, no? Nag step 6 and step 7. Okay? Yung step 6, ginagamit natin yung ACF and PACF para malaman natin kung ano yung best na AR at saka MA model. Okay, when I was studying, guys, nung inaaral ko itong time series several decades ago, no? Ito yung ginagawa namin. So, manually, ang hirap mag-plot nito. Ipa-plot mo yung ACF at saka PACF. It's so hard to plot that. Tapos aalamin mo pa, trial and error, ano kaya to? AR model kaya to o MA model kaya to? Okay. Saka natin ma-identify yung best fit na ARIMA model. Okay. Ngayon guys, with R, hindi na natin kailangan to, no? Itong step 6. Kailangan, ang pwede natin gawin guys, automatically may function na auto.arima. So bahala na yung R mismo, bahala na siya mag-determine, magbibigay siya ng different models, okay? Tapos pipili tayo doon. Okay, may basis naman. Sasabihin niya, ito yung best model. Okay, so di ba ang dali ngayon guys because of softwares like R. Dati, hirap na hirap kami, no? Hirap na hirap kami nagmo-modeling kami nito kasi nga wala pang R noon. Hindi ko pa alam yung R, wala pa ring R noon sa market. So yung mga softwares noon na ginagamit sa time series, million, no? They were really very, very expensive. Tapos konti lang may mga ganun lang, yung mga government agencies. Okay? Not all schools have it. LaSalle did not have it at that time. So, siguro UP lang at that time. Okay, so itong step 6 na to guys, madugo ito. Buti na lang guys, hindi na natin kailangan gawin to kasi pwede na natin ma-identify yung best ARIMA model by virtue of functions. Okay, may mga functions na ngayon guys na automatic ibibigay na sa atin. But it will be good for us guys to know then, no? At least theoretically alam natin kung paano pinili ng auto.arima yung model na yun. Okay? So after choosing the model, forecast na natin yung model natin using the best fit. And then, ang gagawin natin, iti-test natin yung model natin. Titingnan natin yung residuals natin. No? Yung residuals, ipa-plot din natin yung ACF and PACF to make sure guys na dapat yung ano din natin yung residuals natin, dapat white noise na yan. Dapat random na lang yan. Dapat walang pattern yan. Okay? So that in a nutshell are the steps that we need in order to model yung ARIMA. Okay, balikan na natin ngayon yung stationary time series kasi ito yung pinaka core ng natin ng time series analysis. Okay, by definition, ano ba yung stationary na time series? Sabi dito, dapat yung statistical properties niya like the mean, the variance, the autocorrelation, dapat constant over time. Okay? So dapat yung mean constant siya. Paano magiging constant yung mean? Dapat walang trend. Kung paakyat guys yung data natin, kung may trend siya na pataas o pababa, hindi constant mean yun. Okay? Gets nyo guys? Kunyari, yung data natin, umaakyat pataas. Because it's going up guys, then that's indicative that hindi stationary yan. Okay? Kasi hindi siya constant over time. Ibig sabihin ko guys, when we go to time t and then get the average of the data there, iba yung value niya. Kung pupunta kayo dun sa time t plus 10 kunyari, iba na ngayon yung average niya at that time. Okay? Mamaya makikita natin to. So, dapat constant siya in mean, constant in variance. Ano naman yung constant in variance? Ano yung constant in variance, guys? Ibig sabihin nun, guys, yung volatility niya constant. Ibig sabihin, hindi siya parang yung, alam niyo yung nagfa-fan, yung parang pabukas na ganun, okay? And may fanning effect. Hindi pwede yung ganun na data series. Kasi pag ganun yung time series, yung pwedeng wala siyang trend, hindi siya paakyat, pero yung range niya lumalaki over time. Makikita natin mamaya yan. No? So, sorry guys, I'm just explaining the concepts first. Okay? So, kailangan guys, constant in mean and in variance and in correlation yung data natin para ma-consider siya as time series. So, as stationary. So, stationary series guys looks like a flat one, walang trend. Okay, constant yung variance niya and constant yung autocorrelation. Ano ibig sabihin ng autocorrelation? Hindi related yung previous value, yung previous values sa sarili niya. Okay, so dapat wala tayong makikitang pattern na ganun. No periodic fluctuations. Okay. So may iba pang definition dito. Sabi dito, yung properties ng time series does not depend on the time at which the series is observed. Okay, sabi ko nga, kung titingnan natin yung isang series na may trend na paakyat siya, if you take a look at time t is equal to 5 for example, okay, and then get the average, and then compare it with time is equal to 10, get the average, medyo magkaiba, no? So dependent dun sa time yung average niya. Habang tumatagal ka, habang lumalayo ka, kunyari time is equal to 100, kung may trend yan, iba na yung average at that time kasi napakataas na ng value niya. Okay, I hope you're getting me. Imagine guys, yung isang time series na pataas ng pataas, paakyat ng paakyat. No? Kung kunin mo yung average at time t is equal to 5, tapos i-compare mo sa time is equal to 100, kasi pagdating mo sa time is equal to 100, ang laki na ng value eh. So ibig sabihin, magkaiba na yung average nila. No? So that means that that kind of a time series is not stationary. Okay, kasi nagdi-depend sa time yung properties ng time series. Kaya ito sabi natin, yung mga time series na may trend, na may seasonality, hindi sila stationary. No? The trend and seasonality will affect the value of the time series at different times. Okay, let's take a look at some examples. Okay, pakibuksan nga ito guys para ma-illustrate lang natin, no? Kindly open that. Okay, nabuksan ko na yata yan. Just to illustrate to you an example of a... Okay. Tingnan ito guys. Take a look at this. So ito guys, kita nyo, di ba? Walang trend. It does not grow over time. Tapos yung variance siya, if you take a look guys, constant yung variance niya. Okay, may volatility pero hindi it does not change over time, no? Kasi pag may volatility yan, medyo pa ganyan yan, para nagfa-fan out yan. Lumalaki yung variation niya over time. So this is an example of a stationary time series. And that's what we're targeting. Kasi itong stationary time series, mas madaling ma-model yan kaysa dito sa baba. Tingnan nyo to. O yan, tingnan nyo, guys. What do you see, guys? Dito, sa portion na to, guys, kung kunin mo yung average, dito siya. Pero pagdating dito sa time na to dito, yung average ng ano mo ng values ito, iba na. No? So may trend siya kasi pababa yung trend niya. So pag may trend guys, hindi stationary yan. Okay? It's not constant in mean. No, sa variance, hindi naman masyado, no? Hindi naman siya masyado, hindi yung variation niya hindi ganoon ka hindi ganoon ka except dito, no? Grabe na yung variation niya, no? Medyo lumalaki-laki na yung variation niya dito. Okay, so that's an example guys of a stationary time series vis-a-vis a non-stationary time series. Let's take a look at another one. Ito. Control C. Open ko na ba yan? Okay, maganda din discussion dito, no? Stationary. Kaso nga lang medyo mathematical siya. Okay, pero tingnan natin yung diagram dito sa baba. Okay, take a look at this guys. Pareho lang pala, no? Pareho lang pala yung pinanggalingan nito. Okay, dito sa baba yata meron pa. Okay, tingnan nyo to guys, no? This is what I wanted to show you. Okay, ito, stationary mean, stationary variance. Ibig sabihin guys, yung band ng volatility niya, ng dispersion niya, constant lang. Tapos wala siyang trend. So this is the one that we want, yung data natin ganito. Stationary mean, stationary variance. Now take a look at this. Ito, may trend siya. No? May trend. Pataas. So non-stationary mean yan. Pero yung variance siya, stationary. No? Kasi hindi naman, yung fluctuation niya, constant naman over time. No? Yung ano, parang may band lang siya na gano'n. No? Okay? So yung highs and lows niya, hindi naman siya, may konting ano lang dito. No? May konting beyond the 95 confidence interval yan. Okay, but not so much, no? So this is an example which is non-stationary in mean, but stationary in variance. And this, on the other hand, is an example of stationary mean, but not non-stationary variance. Kasi tingnan nyo guys, no? Over time, yung average niya, andito pa rin eh. Wala siyang trend, no? Hindi naman siya umaakyat. Hindi siya bumababa. Okay? Constant siya sa mean, pero tingnan nyo yung variance, no? Over time, lumiliit siya. Yan. Parang nagpa-fanning effect. So it can be pataas over time, yung band ng volatility, or pababa. Compare that with this one, guys. No? Yung volatility dito at saka yung volatility dito, constant. Okay? So pause muna ako, guys. Clear ba yung concept ng stationary mean, stationary variance, vis-a-vis non-stationary mean or stationary variance, and stationary mean and non-stationary variance? Clear ba guys? Paki-chat naman please kung clear siya. Okay, good. Salamat ha. How about the rest guys? Okay, so pag time series guys, hindi pa pwedeng hindi natin alam to, no? So parang ABC yan ng time series. When can we use Box-Jenkins model? Dapat stationary in series. Stationary in what? Stationary in mean, stationary in variance. Kasi actually guys, may iba't ibang levels ng stationary, no? May strict stationary, tsaka may weak stationary. Ang kailangan lang natin guys yung weak stationary. Yung strong stationary, that medyo mas very strict na yung requirements, no? So for our purposes, for our time series analysis, we just need yung weak stationary. Nabanggit ko naman yan sa notes natin. No? So pag sinabing weak stationary, ito yun. Okay. Alright, so let's proceed guys. At tuloy lang natin yung yung discussion natin. Okay. Alright, pag sinabi natin stationary, another name for that is a white noise, no? A white noise. By the way, meron akong binanggit pala kanina dito. Ito. Ito, no? Ilagay ko nga ito dito. Okay. This is the model for an AR1 process. Tingnan nyo to guys, no? ito, y sub t is equal to y sub t minus 1 plus error term. Now, this is not an AR1 process. Tignan nyo guys, yung A1 wala, oh. Walang A1 dito. No? Wala siyang A1. Ang AR1 guys, dapat may value yung A1. We will discuss kung may limitations ng A1 na to. Kung ano dapat yung value niya. Ito walang A1. A1 here is equal to 1. Pag ganito yung model guys, this is not an AR process. Rather, this is called a random walk. Okay? Random walk siya. No? Okay, babalikan natin yung concept ng random walk kasi ginagamit din sa financial. So marami tayong terms, ano? Stationary, stationary in mean, stationary in variance, non-stationary, ARIMA process, AR process, MA process, etc. And then we have white noise, no? Okay, ano yung white noise? Ang white noise, guys, stationary yan. Another name for stationary is white noise now. It does not matter when you observe it. It should look much the same at any point in time. So yun, di ba sinasabi natin ano? Ng stationary. In general, a stationary time series will have no predictable patterns in the long run. Of course, time plots will show the series to be roughly horizontal siya. Okay, pwede may konting cyclic behavior, pero dapat may constant yung variance. No? Okay. Okay, so pag nagfo-forecast tayo guys, kailangan, kasi based on the assumption that stationary yung data natin. Okay? So that's why we have, sabi ko nga kanina, bakit kailangan i-convert sa isang stationary date time series? Kasi mas madaling i-predict, mas madaling i-model guys kung stationary. Mas mahirap i-predict kung non-stationary. Okay, so bakit natin papahirapan yung sarili natin? I-ano na lang natin muna, i-transform natin yung data natin. Sabi ko dito, pag stationary data series siya, mas madaling i-predict. No? Okay, you simply predict its statistical properties. You simply predict that its statistical properties will be the same in the future as they have been in the past. Okay, so yan ang reason kung bakit guys, kino-convert natin into a stationary data series. Okay? All right. So mag-example muna tayo, no? So we will use the data from saan ba nanggaling tong ano na to? I think it's from ano nga natin? Air passengers. May data tayo na air passengers which comes with, kalimutan ko kung saan galing to na ano. So dito lang sa console guys, nag-help ako. Ayan, okay. All right, so this comes from the package data sets, okay, which comes with base R already. Okay, so tinalan natin guys kung ano ba laman itong data na to, monthly air passengers. Okay, ito yung classic to na Box and Jenkins airline data. I think this was the data used by Box and Jenkins. So ito, monthly total of international air passengers from 1949 to 1960. Okay? So nanggaling siya dito kay Box, George Box, and nakalimutan ko ano yung first name ni Jenkins. Okay? Yung textbook nila ng 1976, matagal na. Okay, so I leave you guys to try yung ano dito, ano, yung mga codes dito. Okay? Yan ang kagandahan sa help function ni ano. Ito guys, yun niyo, nag-ARIMA siya dito. Classic airline model, yung ARIMA. Okay, after our discussion today, pwede nyo tingnan to, no? That will give you a good appreciation of the process, no, ng Box-Jenkins approach. Okay, so balik na tayo dito. Okay, let's upload yung data na air passengers. Okay, i-view natin siya. Okay, so univariate lang siya, no? Isang variable lang. 144 observations. Ano kasi siya from 1949 to 1960, so that's 12 years. Monthly data, not 12 years, so that's 12 times 12, that's 144 na, no? So yung data natin na airline passengers, that comes from the datasets package. Lagay na lang dito. Lagay ko dito, no? From data sets package. Okay? So, view na natin siya. Tapos, palitan natin ng pangalan, AP na lang para mas madali natin ma-access. Okay? So, tanggalin ko na yung view dito kasi pareho lang naman yan. Okay. So, let's rename the air passengers as AP. Okay. So, may AP na tayo, no? If you click that, okay, ba't ayaw? Rinan ko na. Oh, rinan ko na. Okay. Anyway, si AP guys, air passengers din yan, no? Sige na nga, i-view na nga natin para view AP. Sigurado lang. Pero yun na rin yan. Yan, si AP. Same. Same as air passengers. Rename lang naman natin si air passengers. Okay? Guys, okay? Na-download nyo na guys yung ano? Yung AP, airline passengers na data. Feedback please guys. Okay na? Okay, thank you. Okay? So, as always guys, tingnan muna natin yung yung data na to, no? So, ito yung data natin na AP. Okay. So, ito yung year niya, no? Yun, 1949 to 1960. January, February hanggang December. So, ito yung data natin. Time series siya. Okay, monthly data from 1949 to 1960. Ito yung last data. 1960 ng December. Okay, so we can get the structure. So this is a time series data, no? From 1949 to dapat 1960 lang to. 1960. Kasi 1949 pag sinama natin sa bilang 1949 to 1960, that's 12, no? All right. Tapos tinan din natin, although nakita naman natin na walang missing data, no? Wala naman missing data kanina. Pero how do you check that? I-sum natin lahat ng not NA. Ibig sabihin may missing data. So let's sum it 0. Okay, ano ibig sabihin yan guys? Ano ibig sabihin yan guys? Anyone please? Ano ibig sabihin ng 0 dito? Ibig sabihin, wala siyang missing data. No? Okay? Importante malaman natin kung may not missing data niyan. Kasi minsan, lalo sa time series, pag may nagmi-missing data, hindi mo mamamodel siya, nag-error siya. Okay? How about frequency? Ibig sabihin monthly to, no? Monthly data. Okay, ano yung cycle? Okay, ito yung cycle niya, no? 1 to 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 1 to 12, 1 to 12. So monthly nga siya. And then, na-summarize na ba natin ito kanina? Hindi pa. Summary naman. Okay, so this is the minimum value. Tapos yung maximum, 622. Okay, so yung average ng data natin is 280. Okay. Okay, now, of course, guys, sabi natin ang first step, kailangan malaman natin kung stationary. Oh, thank you, Masahiko. You're correct. No missing data. Okay, that's what that means. Okay, so sabi nga natin, first and foremost, okay, alamin natin kung stationary yung data. So, paano natin malalaman kung stationary yung data? I-plot natin. Okay? So, we can make use of this function from the base R, yung plot function. Ito, no? So, ipa-plot natin. Let's create an object called P1. I-plot natin si AP. Lagyan natin ng label, yung X. Yung X natin is, yung X natin is your date. Okay? Yung Y label natin will be passenger numbers in thousands. And then yung main plot natin, bigyan natin ng pangalan, air passenger numbers from 1949 to 1960. And then i-print natin si P1. Okay, there guys. Ayan. Kitang-kita na hindi siya stationary. Bakit guys hindi stationary? Unang-una guys, ano? Anyone please? Is the data stationary?
No, sir.
Bakit no? Fourth.
May trend, sir.
May trend, yes. Thank you. That's good. May trend. Oh, may trend. Of course, there are models, guys, that can be used in order to predict this. Pwede yun. Mga smoothing, mga exponential smoothing. Kaya ding i-model yan. Kaso, sabi nga natin, ang aaralin natin dito yung ARIMA process. No? So, we cannot use ARIMA for this. We have to convert it into a time series. How about stationary ba siya? Hindi siya stationary sa mean, no? Stationary ba siya sa variance? Guys?
Yes, sir.
Sa variance? If I draw a line here, a straight line, yung band niya, yung variance ba niya constant? Fourth?
No, sir.
Hindi, no? Kasi nag-i-increase siya over time, yung fluctuation niya. Okay, so this is indicative na, tingnan nyo, i-draw ko yung line na from here hanggang sa dulo, from here hanggang sa dulo. Di ba? Parang fan siya. Palawak siya, palawak. So that's an indication that this is not stationary as far as variance is concerned. Compare nyo dito guys, yan, no? Di ba? As against this one. Yung sa atin, yung AP data natin, reverse. Reverse nito, no? Nag-i-increase yung variability niya over time. Okay, thank you Matthew. May trend siya, thank you Aubrey. Tapos hindi siya constant, hindi siya stationary in variance. No? Okay, good, good. So, nakukuha niyo yung natin, yung lesson natin. Okay, of course, there's another way to do this. We can use the autoplot. This is from the GG45 package. Okay, if we plot this, kasi na-load na natin si GG45. Okay, ganun din, nagkaiba lang guys sa autoplot. Kaso iba yung syntax niya, no? Autoplot yung AP plus, yung label. Okay, this is how sa ggplot. Those of you who are my students in FINTSAR, alam nyo na ganito yung syntax ng ggplot2. Okay, plot natin. Okay, same lang naman. No? Okay, same lang. Okay, choice na lang kung anong gusto nyo. Okay, so, all right. Now we can also use the box plot. Yung box plot, oh sorry, this should be small AP. AP, okay. Tapos ipa-plot natin vis-a-vis the cycle. Lagyan natin ng label, etc. And then box plot, kasi box plot function to. Okay. So this is also an instructive plot, no? So ito lahat ng, what's this, guys? Ano yung 1 dito? Ano kaya yung 1 dito, guys? Is yung 1 ba dito? Ito yung ano? Ito yung 1949, 1950, 51, hanggang 1960, yun ba yun? Hindi guys, kasi cycle yung ginamit natin eh. Diba? Yung, ano ba yung cycle guys? Diba ang cycle natin yung 1 to 12? Diba? So yung 1, yung month 1, yung 12, yung December. No? Yeah, correct. Thank you Masahiko. So yung month to. So pinaplot natin dito guys yung box plot on a monthly basis. So kinuha lahat ng January, kinuha lahat ng February, kinompute yung median, di ba? If you recall guys, yung box plot, ito yung first quartile, ito yung second quartile, ito yung third quartile, no? Eh, di ba? Ito yung ano, ito yung maximum value, ito yung minimum value. Okay. If you look at this guys, papansin natin na pinakamataas yung mga medians ng June, July, and August. Sila yung medyo hanggang September. No? Ang pinakamataas talaga si July, yung median niya. Tapos pinakamataas din sa maximum value siya. So medyo nagpipik yung mga passengers, yung passengers, June, July, August, sila yung pinakamataas na month. Ang medyo mababa, February, November, sila yung medyo mababa. Okay, and then just some notes about that, no? Okay, so I won't pakibasa na lang nito, guys. Passenger number increase over time. Okay, with each year may be indicative of an increasing linear trend. Okay, talagang kita naman natin dito sa plot natin dito, may trend talaga, no? There's a linear trend. Okay, tapos, okay, let me skip that. Basahin na lang yan, guys, no? There appear to be no outliers. Paano natin nalaman na no outliers? Paano nalalaman, guys, ang no outliers? Walang values na outside the whiskers, no? Ano tong value na to, guys, if you recall? Ano tong height na to? Ito. Kalimutan nyo na? Okay, kalimutan nyo na, guys. So, konting review, guys, ng bar plot, ha? Yung box plot, ha? Kasi, nandiyan yung IQR. Madali lang naman yan. Konting review lang ninyo, no? Okay, but I won't discuss that anymore. Okay. Ngayon, meron tayong tinatawag na seasonality. Okay, hindi ko pa na-mention kanina, no? So, merong trend. Ano ba yung composition ng time series? Pwedeng magka-trend siya, pwedeng magka-seasonality. Ano yung seasonality, guys? If you notice, guys, ito, may seasonality siya, di ba? Ibig sabihin, at constant time of the year, tumataas, tapos bumababa yung time series natin. We call that seasonality. So there are two types of seasonality. You have additive seasonality at saka you have multiplicative seasonality. Okay, anong difference ng dalawa? Okay, let's just get this diagram, Control C. Okay, very easy to differentiate between additive seasonality and yan, okay? So I'm using this references sa internet para makita nyo, guys. Tingnan nyo to. No? Anong difference ng additive seasonality at saka multiplicative seasonality? Anyone? Anyone, guys? Okay, ang seasonality, guys, di ba sabi natin at specific periods of time, no? Parang nagre-repeat yung process. Diba? Para yung sa natin, yung sa AP. Diba? Na-notice nyo kapag may mga peaks and troughs. Let's go back to our model here. Ito. Diba? May mga peaks siya. Saan kaya yung mga peaks na yan? Saan yung mga peaks na yan, guys? Okay, based on the box plot, guys, saan siya? Most likely it will be dito sa July, no? July at saka August kasi sila yung pinakamatataas na maximum values at saka sila yung matataas na median, no? Look at this. Ito yung mga median nila. Sila yung matataas na values. So most probably, guys, ito July, August to mga to, no? And you notice consistent na July, August sila yung matataas. We call that seasonality, no? Now, dalawang klaseng seasonality, additive at saka multiplicative. Ang additive seasonality, guys, constant lang. Constant over time yung seasonality niya. Okay, this is an example of a multiplicative seasonality kasi yung multiplicative seasonality, guys, habang tumatagal, tumataas yung volatility niya, no? In fact, guys, pag additive seasonality, balik tayo dito. Okay, ito guys, additive seasonality. Ano siya? Stationary mean variance ba siya, guys? Yes or no? Stationary variance ba siya? Stationary invariance ba siya, class? Yung fluctuation niya ba lumalaki over time? Hindi. So, di ba? Sino yun? Aubrey, bakit hindi?
Yung fluctuations ko, hindi po siya nag-increase over time.
So, stationary siya invariance, di ba? Non-stationary in mean siya kasi may trend. Pero stationary invariance siya. Okay? Another name for stationary invariance, kapag guys kapag may seasonality, okay? Pag additive seasonality, ibig sabihin nun, stationary invariance siya. Kapag multiplicative yung seasonality, ibig sabihin non-stationary siya sa variance. Okay, so that's the difference, no? Okay, I hope that's clear. So yun ang pinapakita natin dito sa yun ang pinapakita natin dito sa additive at saka multiplicative seasonality. Okay, let me clarify that again, guys. Seasonality, guys, ibig sabihin merong points in time na parang nagre-repeat siya. Kunyari, if you plot let's say a company that sells, let's say, flowers and Christmas items. Kunyari, pareho niyang binibenta yun. You'll notice that pag flowers, tumataas yan pag February. Tumataas pag November. Because of the dun sa All Souls Day, no? And tumataas din pag December kasi Christmas items. Okay, so yung ganun mga products, guys, may seasonality. Kaya ang question na lang, additive ba yung seasonality niya or multiplicative yung seasonality niya? Okay? So pag additive seasonality, hindi nag-fluctuate yung variation niya. Constant lang. Pag multiplicative yung seasonality niya, may nagfa-fan out yung seasonality. Bilis ng oras. Nasa 1:42 pa lang tayo. Okay, now one thing good about we can make use of the decompose function. Saan ba itong decompose function na to? Saan galing to? Check natin, decompose. Okay, so decompose function comes from a stats to. No? So yung stats kasi, hindi na natin siya ini-install kasi it comes with R already. Anyway, para just to remind us that this is from the stats package. No? So I'm writing here the namesake, no? Stats, and then decompose. So the decompose natin, either kasi additive yan or multiplicative. So decompose, add, additive, no? Then i-plot natin. No? Okay. So you can see here, guys, na na-decompose yung natin, yung time series natin. Okay. So ito yung data natin, original data. Ito. Okay, so dinecompose siya into, ito yung trend. Okay, positive yung trend. Tapos ito yung seasonality niya. Okay? Sabi natin gawing additive seasonality. Tapos ito yung remainder. Ibig sabihin, ito yung hindi ma-model. Okay? Ito yung if you add the trend and the seasonality, kung ano yung natitira, as compared to the data, ito yung remainder. Alright? So let's go to, pag ano naman, kapag multiplicative, okay, ito lang. Okay, we just use multiplicative. And yung difference talaga ay sa modeling. Okay, kasi ang additive model, pag minodel natin yan, it's the time, ang time series natin is equal to the trend plus the seasonality plus the remainder. Pag multiplicative, yung series natin is equal to the trend times the seasonality times the remainder. So yun ang difference sila, no? Pag nagmo-model tayo ng additive, ganito yung function na ginagamit. Pag nagmo-model ng multiplicative, ganitong function yung ginagamit. Okay. All right. Now we know, guys, that the series is not stationary, no? So meron ba tayong pwedeng gamitin na statistical test? Visually, guys, sabi natin hindi siya stationary. Pero how do we confirm that using a proper statistical test? Meron, no? We can have this, ang tawag dito, augmented, para alam natin, Dickey-Fuller test. Okay? Augmented Dickey-Fuller test. Sorry, dapat AP to, small AP. All right. It comes from the time series package, ADF.test, augmented Dickey-Fuller.test. Ito yung syntax niya. Yung object natin, AP, alternative is equal to stationary. Ano ibig sabihin nito? So, alternative is equal to stationary. Ibig sabihin, ang null hypothesis natin, non-stationary yung ano natin, yung time series. Okay, non-stationary yung time series. K is equal to 12. Okay, let me clarify muna kung ano yung K equal to 12. Is the K the cycle? Okay, babalikan ko na lang kayo, guys. No? Nakalimutan ko kung ano yung K dito. So let's run this. Okay, so this is now our statistical test. Okay, ang null hypothesis natin, the time series is non-stationary. Okay, what do we have here? Tama, log of order 12. The p-value is 0.7807. So that means we fail to reject the null hypothesis that our time series is non-stationary. Okay, we fail to reject this hypothesis. So it turns out, guys, that indeed, na-confirm lang natin, no? Pero obviously naman, guys, sa plot natin, kitang-kita nyo na kagad na non-stationary yung series natin. So kinonfirm lang natin via a statistical test, no? Okay, so that's the ADF test, and it tells us that we can have confidence that indeed our time series is not stationary. Okay, or dati, guys, ang ginagawa, no? Pinaplot yung ACF at saka yung PACF, yung autocorrelation function at saka yung, mali ito, dapat small AP, at saka yung partial autocorrelation function. Okay, we'll just plot this. Okay, pero I'll leave you guys to research muna. Ano ba yung paano natin masasabi kung stationary yung data series using ACF at saka yung PACF, autocorrelation function at saka partial autocorrelation function. So this is the syntax. Okay, autocorrelation function ng data natin na AP. Tapos dito, pinapakuha niya yung log. Ibig sabihin ng log.max30, kukunin niya yung yung correlation ng time t at saka t-1, tapos time t at saka t-2, time t at saka t-3, time t at saka t-4. Kinukuha niya yung correlation nila. Kaya nga ang tawag diyan autocorrelation. So what's being computed is correlation. Okay? Illustrate ko lang. Kunyari, correlation nito, ito, Okay, ito yung data natin, di ba? At saka kukunin niya yung time t minus 1, itong data na to. Yan. So this data at saka yung data na to, kukunin niya yung correlation. That's that's log 1. Ang log 2 naman, itong data na to at saka yung two values before, tsaka ito. Siyempre dapat pare-pareho yung yung size ng data natin. So yun ang ibig sabihin ng log 1, log 2 hanggang log 30. So pwede natin gawin yung log 30 kasi malaki naman yung data series natin, 144, no? And then so kukunin niya yung autocorrelation nun. Okay, so i-plot natin to. Okay, so we have PACF at saka ACF. Okay, so ito yung autocorrelation function, no? Okay. Ito yung correlation ng series with itself, kaya 1 yan. Ito guys, yung value ng correlation ng series at saka yung t-1, yung 1 past value. Ito 2 past values, 3 past values, hanggang 30 past values. Okay? Now you notice guys na medyo correlated talaga sila, no? Okay? Ibig sabihin, correlated yung value ko ngayon at saka yung value ng at time 10, no? Okay, so that will indicate guys na hindi stationary yung data natin. Kasi dapat guys, di ba pag stationary, dapat walang correlation. Dapat kung may correlation man, constant dapat yan over time. Ito hindi constant, no? Okay, so this is indicative of a non-stationary data. Pati ito din guys, itong PACF. Okay, so ang question, how do you now read the PACF in terms of stationary? Okay, so dapat kasi, as much as possible, yung mga natin, yung autocorrelation, dapat hindi siya autocorrelated, no? So dapat yung mga values siya andi dito lang sa band na yan, sa blue band na yan. Okay, so this definitely indicates that hindi stationary yung data natin, no? Okay, so ito yung ginagawa namin guys nung visual pa yung pagtingin ng kung stationary yung data o hindi. So I'll leave you guys to research on how to use how to use ACF and PACF to determine if the data is stationary, no? Okay, so we just want you to get the hang of that, no? Although since may statistical test na naman tayo, parang nagiging na lang to, parang nagiging secondary importance na lang. Okay, we can of course use this one. Okay, pareho lang naman ilalabas yan, no? Yan, PACF and ACF. Same. So, saan natin ginagamit tong ACF at saka PACF? Number 1, ginagamit natin yan para malaman kung stationary yung data natin. Number 2, pag nag-model na tayo, we want to determine if the residuals, pag nagmo-model na tayo, gusto natin malaman, based on the stationary data, what AR or MA model to use, no? Sa ngayon guys, yung AP data natin, hindi stationary. So ang gagawin natin, magta-transform tayo ng data na yun. Magdi-difference tayo o maglo-log transform tayo. Once we have done that, we now have a new series, no? Either the difference series or the log transform series. So ang gagawin natin dun sa data na yon, kukunin din natin yung ACF at saka PACF nun. Tapos, yung bagong ACF at saka PACF na yon, yun ang gagamitin natin para malaman natin kung anong klaseng AR model yon, or MA model, or ARMA or ARIMA. Okay? So I hope you're getting the picture guys. Although theoretical pa lang to, kasi magtatalagang numerical example tayo, no? I'm just laying out the concept behind. Okay? Let me summarize ulit. Check, plot the data, check if it's stationary. Kung hindi stationary, transform the data. Okay. Wait. Check if the data is stationary. How do you check if it's stationary? Number 1, visual. Okay. Number 2, more importantly is a statistical test, no? Yung augmented Dickey-Fuller test. Number 3, visual din, yung ACF at saka PACF. Autocorrelation function at saka partial autocorrelation function. Okay? So second, transform the data. Pag na-transform na natin yung data, and then ipa-plot ulit natin, makikita nyo guys na ano na kung stationary na siya o hindi. Again, yung tatlong test pwede. Yung transform na data, tingnan nyo, i-plot nyo, stationary na ba siya? Mag-augmented Dickey-Fuller test ulit dun sa transform data, at saka mag-ACF, PACF test ulit kung stationary na siya. Okay? Pag na-transform yung data, malamang guys, makikita nyo rin sa ACF, PACF na stationary na siya. Tapos, yung ACF and PACF na yun, yun ang ginagamit natin para ma-determine natin kung AR process ba siya or MA process ba siya. Eh, dati, trial and error yan, no? Sabi ko nga dati, ganun na ginagawa. Pero ngayon guys, may auto-arima function ng CR which makes it really very convenient for us. Which we're going to study. Hindi natin definitely aabutin ngayon yan, pero next Tuesday aabutin natin definitely yan. Okay, so okay, I'll just leave you guys to to read through this. Sabi ko nga sa inyo kanina, if the data contains a trend, then ano sabi dito? We can just pwede nyo i-regression na lang kung simple lang naman yung trend. Pwede mag-regression na lang. Pag nag-regression tayo, hindi na ARIMA yan, no? If we want to use ARIMA, tatanggalin natin yung trend. For non-constant variance naman, kailangan kunin yung log ng data or pwede ring square root ng data para ma-stabilize yung variance. Okay? So these are some techniques of data transformation. Okay. So some notes about the ACF, okay, and the PACF. Okay, so I leave you guys to read on this, no? Okay. It's time already, so sadali lang ha. Okay. Magpapakita lang ako guys ng isang may I have guys 1 or 2 minutes? Pwede ba? Permission lang, no? It's already time. Thank you, thank you. I hope guys na intindihan natin ha. Ito, nagbigay na nga actually ako ng notes dito yeah, I think I remember yung paano natin malalaman kung AR yung process using the ACF and PACF. Ito yun guys, oh. Kunyari, stationary na yung data natin, ano? Tapos plinat natin yung yung ACF and PACF. Okay, paano mo malalaman guys kung kung AR process? You look at the ACF guys, yung plot, pag AR process yan, yung ACF niya, gradual decay. Tapos pag yung PACF naman yan, may spike, significant spike at log P. Baliktad naman sa MA process, no? Anyway, pakita na lang natin yan next meeting pag nag-formal na tayo na modeling. Okay, dito, last na to guys. Okay? So, nagmo-model tayo nito, no? Model natin dito, ARP model. Okay, ito yung mga A1, A2, A3, A4. Okay, yung mga coefficient ng A1, 0.7, 0.2, negative 0.1, negative 0.3. Okay, take note guys, yung mga coefficient ng AR model. Okay, yung AR model, dapat yan less than 1, no? Dapat yan less than 1. We'll discuss that in greater detail. So sige nga, i-run nga natin to. I-run natin yung unang set that seed para kasi randomize to, no? And then AR.models, list natin. And then ito na yung function natin na gagamitin. Magsa-simulate siya ng ARIMA ng 10,000 times. Okay? So i-run na lang natin yung buo para Okay. So what do we now have here? Meron na tayong what do we now have here guys? Ano yung object natin dito? Okay, dito. Yan, meron na tayong ARP, di ba? Meron na tayong asan ito? Yan, AR mods, no? Yan, we now have guys yung AR mods natin sa taas. Okay, so we'll just continue with this next meeting guys, itong AR mods natin. Yan. So naka-generate na tayo ng AR mods. Tapos, i-plot na lang natin last. Okay, last. Okay, so this is now plotting it. There. Okay, so apat yung model natin, AR1, AR2, AR3, AR4. Iba-iba guys yung ano nila, iba-iba yung coefficients nila. Okay, take a look at this guys. Ito yung ACF, ito yung PACF. Notice guys, pag AR, yung ACF niya constant decay, no? Bumababa over time. Tapos may significant spike sa PACF. Okay, ito yung sinasabi ko sa inyo kanina. Ang AR model, pag tinignan niyo yung ACF niya, nagdi-decay constant. Tapos yung PACF niya, may spike. One significant spike. No? Ito lang. Okay? So ito din yung AR3 natin, one significant spike, etc. Okay, so tingnan nyo na lang guys. Thank you so much for your patience. What I'd like to request you guys is i-compare nyo siya dito sa MA, no? Tapos ano yung difference sila? And then we'll pick it up from here next meeting. All right? So let me end our discussion now. Stop recording. Okay, thank you so much guys. So